welcome back to my channel. I hope that you are doing absolutely fine. Today, in Introduction to Mensuration Part 4, we are going to see two very important concepts. So make sure you watch this video till end, and if you have any doubt, you can just mention in comment. I will surely reply. See, before starting with this video, make sure you have watched Introduction to Mensuration Part 3 because this video is partially connected with that video. So before watching this video, make sure you watch Introduction to Mensuration Part 3. Let's begin with this video. Now here first concept that we are going to study is sector. Now remember one important thing, sector is a part of circle. Don't forget this is very important. Sector is a part of circle. So let's consider one circle with center O. Also let's draw two radius in this circle. First is AO and other is BO. Now if you observe carefully, this entire circle is divided into two parts. See, as soon as we draw two radius, this entire circle got divided into two parts. Let's shade one of the region. So if I shade this smaller region and the other region is the bigger region. Now observe this smaller region or the yellow part carefully. If you observe this yellow part, this region is enclosed. It is between or it is enclosed between two radius and one arc. See, observe this yellow region is between two radius. One is AO and other is BO and one arc AB. So any region that is enclosed between two radius and one arc is called as sector. So this yellow region is nothing but it is a sector. Sector is a part of circle and it is enclosed between two radii and one arc. Now if you observe this yellow region or this yellow sector carefully, we have one central angle. Since the measure of that central angle is unknown, let's mark it theta. Now let's try to understand how do we calculate area of this sector, this yellow sector. How can we calculate area of this sector? See, now observe this central angle carefully. This theta is part of that entire circle and we all know that measure of entire circle is 360 degree. Now this sector or this theta is one of the part of that 360. That means this sector got theta part from that 360. That means this sector got theta out of 360. That means we can write it as theta upon 360 since this sector got theta out of entire circle, that is entire 360. Also if you observe, we have shaded the region inside the circle. So that means the region which is inside the circle is called as area of circle. We all studied that. So here in continuation we'll write area of circle, formula for area of circle, that is pi r square. So remember this formula, this is very important formula for area of sector, that is theta upon 360 into pi r square. Now if you observe the remaining part, let's shade that part also. Now if you observe this red part, this part is also enclosed between two radii and one arc. See, observe carefully. This red part, it is between AO and BO and the major arc AXB. So if you observe, this region is also a sector which is enclosed between two radii and one arc, but this arc is major arc, so this sector will be major sector. So remember, this red region is major sector and this yellow region is minor sector. Now we have just shaded major sector. So formula for major sector will also be there. So let's see. So formula of major sector is very simple. See, we need to calculate area of this red part. So this red part, how can we get area of this red part? It is very simple. See, observe circle. So if you observe this entire circle, from this circle, if you remove this yellow part, if I remove this yellow part, the remaining part will be the red part. That means you are removing it. That means you are subtracting it. That means area of that red part or the major sector will be equal to area of entire circle minus area of minor sector. That means if you need to calculate the major sector, what we'll do, we'll take entire circle and we'll remove or we'll subtract the minor sector. So area of major sector will be equal to area of circle minus area of minor sector. Also don't forget the area of minor sector, that is theta upon 360 into pi r square. See, now there are two formulas for sector. One is major sector, other is minor sector. In exam, remember whenever in question they ask you find area of sector. So always use area of minor sector, that is theta upon 360 into pi r square. Unless and until they mention find area of measure sector, don't use formula for measure sector. If they ask for measure sector, only then use area of measure sector, or else just use area of minor sector, that is theta upon 360 into pi r square. Let's move ahead. Now, how we can name a sector? See, naming of sector is very simple. What we'll do, we'll first write name of center, then we'll write name of arc. See, for example, this yellow sector, the smaller, the minor sector. For this minor sector, center will be O and arc will be AB. So naming of this minor sector will be O dash AB. And similarly for major sector, center will be O and arc will be AXB. So name of major sector will be O dash AXB. I hope everyone is clear till here. So we have two formulas for sector, that is first is area of minor sector theta upon 360 into pi r square. Then we have area of major sector, that is area of circle minus area of minor sector. Also remember how to name a sector. It is very simple. You have to first write name of center, then you have to write name of arc. Whichever arc you choose, minor arc or major arc, depend on which sector you are naming. Right? If you want, you can take screenshot of this entire page so you can keep it with you for revision. Let's move ahead. Let's see next concept. Now, this next concept is also related with circle. So we have one circle over here. The name of next concept is length of arc. See, we all know what is a arc. In Introduction to Mensuration Part 3, I have told in detail about arc. So if you haven't watched that video, make sure you go to that video. I will put link in description box. You watch entire video, you will understand what is arc, what are the formulas related with arc. Here we are going to learn how to calculate length of arc. See, so in this circle, if we need one arc, we'll take one center O and we'll draw two radius AO and AB. As soon as I draw these two radius, we got one small yellow arc. So this small or the minor arc. Now, this minor arc, we need to calculate length of arc. So what is basically a length of arc? The length of arc is nothing but it is distance of arc. See, if you remove this yellow part from this circle and hammer it and make it straight, so that length or the distance of that yellow part is nothing but length of arc. Now we'll study how to calculate this length of this part or this length of this arc. See, again, if you observe, there is a central angle AOB. So let's mark that central angle as theta since value is unknown. Now here also, if you recollect, this theta or this central angle is one of the part from 360. So length of arc also got theta part out of 360. So we'll write theta upon 360. Next, now we need to multiply it with something. In last formula, we multiplied with area of circle because we shaded entire region inside the circle. Here we just shaded the boundary. Now we all know that boundary means circumference of circle. So here we'll not write area of circle, we'll write circumference formula of circle, that is 2 pi arc, since we have only shaded the boundary of the circle. So length of arc is very simple, that is theta upon 360 into 2 pi r. Remember this formula, this is very important. Now you might be thinking ki this is the length of minor arc, so what will be the length of major arc? See, if you observe the white major arc, we need to calculate length of that arc also. So to get that major arc, what we'll do, if you observe this entire circle or this entire circumference of circle, if you remove that yellow part, if we remove that yellow part, this red part will be remaining. That means length of major arc will be equal to circumference minus, since we remove that yellow part, it will be length of minor arc. So length of major arc will be equal to circumference minus length of minor arc. Remember these two important formula, that is length of minor arc, that is theta upon 360 into 2 pi r, and length of major arc, that is circumference of circle minus length of minor arc. We all know how to name arc. Naming of arc is very simple. So minor arc is named using 2 letter or 3 letter and major arc is named using 3 letter. So here we'll name minor arc as AB and major arc as AXB. So I hope everyone is clear with this part, length of minor arc, length of major arc, and naming of arc. I hope that you understood these two very important concepts, that is sector and length of arc. So make sure you like this video, you share with all your friends, and if you have any doubt you can just message me on Twitter or Instagram with same ID, that is Manjot sir. And before going, make sure you subscribe to my channel. Chalo, we'll meet next time. Goodbye, take care, bye bye.